And to give you some context of those numbers, if data center today is a country, it's consuming more power than France itself. And by 2030, it's projected to be the fourth largest kind of country per se, behind US, China, and India.
Today with AI, this technology is having an evolution which is extremely rapid and, most important, very frequent. You take, for example, the B200. B200 is coming 100% direct liquid cooling, no choice. The 300 is not the same. You can have cooling with liquid or no.
Recently, we worked together to address an automotive customer where the customer was looking at data center transformation for 50 locations across the world, and the time to deployment was a challenge. We looked at prefab as an offer.
A leading bank rolled out a next-generation AI engine designed to detect fraud in milliseconds and personalize every customer interaction in real time. On paper, it was brilliant. In reality, the data center wasn't ready. Power usage surged overnight. Cooling systems struggled to keep up with dense GPU clusters. Hotspots began forming across racks, and AI training jobs meant to run in hours started stretching into days. The infrastructure built for cloud and enterprise apps was suddenly being pushed into a completely different league. And then came the realization. The challenge wasn't the AI. The challenge was everything around the AI. So they made a bold move. They stopped thinking of their facility as a traditional data center and started redesigning it as an AI factory. A place where compute, power, cooling, and software operate as one intelligent system, where energy is orchestrated as precisely as data, where every watt, every workload, and every millisecond is optimized. The transformation wasn't just technical, it was architectural and strategic. Because in the age of AI, performance is no longer just about faster chips, it's about smarter infrastructure. And that's exactly what we are diving into today. How organizations are reimagining their data centers into efficient, resilient AI factories. To unpack this, I am joined by experts from Schneider Electric and Hewlett Packard Enterprise, two companies at the forefront of sustainable AI-ready data center innovations. So thank you, Anand, Elisa, and Christoph, for joining us for this conversation. I think let's start with quick introductions. So maybe Anand.
Hello, Nusrat. Hi, Christoph. Thanks for having us here. My name is Anand Nair. I manage HP Alliances for Schneider Electric for the region of APAC, which includes Japan, India, and Southeast Asia. And I'm looking forward to seeing how we can address AI opportunities with customers and partners. Thank you for having us.
Okay, firstly, thank you, Nasrat and Christopher, for inviting us to be here. It's really a pleasure to be part of this podcast. I'm Elijah. I look after the channel and alliance business for East Asia at Schneider Electric Secure Power Division. And I work very closely with partners, alliances, and distributor, and I'm responsible for shaping the partner strategy, go-to-market execution, and scaling the partner ecosystem.
Yeah, my name is Christophe Meznav. I'm actually based in Singapore for about 25 years. I'm currently leading the hybrid cloud solution team for sales into the region. I've been in HP for about 25 years, same for being in Asia Pacific. I spent about 10 years of my life to design and strategize a data center for our customer across the region of Asia Pacific. So happy to be here and to talk to you today about this subject.
Great. So thank you all once again. To get a conversation started, let's touch the first point. What is basically changing in, say, a data center design? Maybe Christoph, to start with you.
Yeah, so that's a great question. And I think into the story that you gave just as an opening, he explained a little bit the situation, right? In the past, we have been designing or planning data center for at least a life cycle of 20 years. And it was easy to do because everything was predictable, right? So the usage and the density per rack was quite constant for decades, actually. But in the recent past, we have seen actually a big transformation. Yeah. First is this introduction of very large GPU cluster. And these clusters changed completely the conceptualization of a data center. The second thing is also they need to be much more connected. So we see that there is a very big difference in terms of the dynamics for the data to come to these clusters, and also the way the data need to be exchanged from this cluster to other clusters, right? So we see really a complete transformation of that environment, and we are moving from I would say, legacy data center to an AI factory. So AI factory concepts are not only an element of just computation or just power or just cooling or just network, is really a complete redefinition of this type of environment, which is the data center. So this is what we have to deal today with, and this is what people need to transform completely. Yeah.
Lisa, your perspective?
Okay, so just to take a step back, in terms of data center growth, we are currently in hyper growth mode. And what kind of take us 30 years to reach 105 gigawatt of data center power consumption? It's going to take us like 4 to 5 years to triple that to 255 gigawatt of data center power consumption. And to just give you some context of those numbers, if data center today is a country, it's consuming more power than France itself. And by 2030, it's projected to be the fourth largest kind of country per se, behind US, China, and India. So what has driven us to our current 105 gigawatt of data center capacity today is kind of the investment from hyperscaler on the large training data centers. They're built computational heavy, ultra density, and they require thousands of GPU. And the primary goal of such data center have resilience in mind. And what's going to scale out in the next 4 to 5 years are the inference kind of data center that are compact, not so computational heavy. They're built, to be latency optimized and to provide, real-time response to users, machines, or application. And these are driving the different kind of data center build. We have, density scaling from 25 kilowatt right up to above 100 kilowatt of data center capacity. And it's just not a one size fit all. We kind of, the higher the density is scale, the more advanced the technology, the more advanced the infrastructure, and the more ultra efficient cooling is actually required to deploy such data center.
Great. So you touched upon power. In fact, you talked about gigawatt, and you also talked about how the kilowatt density also is going. So that brings to the question of power availability. Yeah. So from an AI workload perspective, so maybe I'll come to you, Anand. Is power availability is becoming a bottleneck for AI workloads?
Yeah, and I'll take the point where Christoph happened to mention about the substantial increase in the power density in racks. What we are seeing since 2021, right, is the consumption of generative AI that has led to substantial increase in accelerated compute. So we are talking about 5 kilowatt per rack, increasing to almost around today 130 kilowatts per rack. And looking at the scale with which the new GPUs are getting introduced, we are talking about a roadmap of 100 kilowatts, even megawatt class racks over a period of time. To address this challenge and make the life of our customers and partner easier, we are creating reference architecture, right, which address the challenge of high power distribution, liquid cooling, and intelligent energy management.
Great. So if this is a concern, then Alyssa, maybe I'll come to you from a Schneider perspective. What do you think, how the CIOs should be thinking today?
I think if we kind of think about AI, AI can be in a flywheel, in a flywheel. AI requires more compute, computes require more energy, and you require more energy to drive more sustainable AI. So by focusing on these two elements, compute and energy, by driving efficiency in it, you can kind of drive more sustainable AI. So here, just to take a step back, back in about 2010 or 2020, kind of the data center power consumption has remained flat, even though there was tremendous growth in data driven by digitization. But right about 2020, the compute efficiency kind of stalled. And we just see, massive global projection of energy consumption rising sharply right up to 2030. And for us at Schneider, we have this concept of bending the energy curve just by kind of focusing on compute efficiency and PUE improvement. You can cut global power consumption by up to 17%. And if I may add on, what CIO should think about is the AC to DC transition. DC data centers are built to be more hyper efficient, and because it has less conversion from AC to DC, it requires less energy, which means less heat loss, and then less cooling required, and cooling kind of attribute to about 30% of the total data center consumption of power. So by focusing on the kind of the AC to DC transition, we kind of improve that efficiency. And also based on NVIDIA roadmap, the Vera Rubin kind of infrastructure is all based on 800 volt DC architecture. So if CIO build a data center that is AC oriented, it kind of run risk of early obsolescence. And if I may, I touch on the last aspect, which is the new energy landscape. The grid is kind of moving from linear to a bi-directional kind of thing. And we have distributed energy resource coming online, which would attribute to kind of 30 to 40% of total generation. And new supplies are coming online like AI data center, energy storage, microgrids, EV cars, AI, as I say, AI data center. And this is driving a decentralization of the grid, and we require it kind of increase the complexity, and we require more flexibility to manage this. As an AI data center moved from energy taker into energy stabilizer.
Great. I think you made a very important point that cooling accounts for almost 30% of the power that goes into a data center. So if we double down on cooling as a concept and as an aspect, so what are the kind of innovations that you're seeing which is coming about in cooling space itself?
So if we talk about liquid cooling deployment, right, liquid cooling deployment will ramp up as the rack density increases. But in terms of technology, liquid cooling has been around for more than 10 years. And early concepts started in 2000, and real kind of serious deployment started around 2010 to 2020. And over the last 3 years, we see massive deployment on liquid cooling driven by AI. I think HPE and Schneider are very well versed in this. For HPE, you kind of run default liquid cooling full stack on your Cray EX supercomputer. And for Motive Air by Schneider, we have been running liquid cooling technology deployment for the last 15 years. We cooled the first 3 exascale system. We cooled 6 out of the top 10 supercomputer in the world. And there's this age-old saying that if a technology is not more than 10 years, data center operators or data center just doesn't deploy it. When you're running mission critical workload, you tend to be very risk adverse. And Schneider and HPE adding our experience together is more than 25 years. So I think we're in a very good position for this. But if I can touch on in terms of technology, we have liquid to liquid, liquid to air, direct to chip, single phase, dual phase. We have immersion, tank top, open bath, IT chassis, immersion. But kind of the technology of choice has become the direct to chip liquid cooling. Propylene glycol solution, because it is very robust, very efficient, easy to deploy, and it's just thermally effective.
Great.
Yeah, but all these technology have been there for, as you mentioned, for quite some time. I think the difference today is to operate that at scale.
Mm-hmm.
Okay, so yes, everybody have been hearing some time back, a long time ago, that somebody was doing something with liquid cooling, direct liquid cooling or door cooling. I mean, technology have been there for very long. The only thing we have been there for very long is actually to operate that at scale. Okay, so the technology are not new, is the volume of usage of this technology, which is really a big new things for this entire ecosystem of the data center or the AI factory, right? Because that's really where is the big change. The other thing, which is also a complication today, is if it's a data center which is going to be today designed, a lot of things can be done from scratch, and it's very easy to implement something when you don't have a legacy. The complexity is when you have a legacy. So the difference into the hyperscaler and the enterprise data center is there. an enterprise data center owner is having a legacy that he need to maximize because these are big investment. And of course, as an enterprise, I have that investment for myself and I cannot share that with too many people. Of course, if you are a hyperscaler, after you fill your data center, you can go and build a new one from scratch, and then your technology can have an evolution at that time. So, of course, the direct DC and so on is very good when you design a new data center. But if you have to retrofit your data center to put some of this technology, then that's where the things start to become even more complex than doing a new data center. Yeah. So we need also to let the CIO be aware about that. You need to make a decision. And I think this high density is making that point of decision very important. Yeah, because the CIOs, they need to say, okay, what is going to be important for me? To retrofit a data center and do that by myself into different methods. So there is different way to do that. Or should I find somebody which is going to build this next generation? Because I will need that technology as soon as possible. Because time is also of a very important element when we talk about AI factory. And what I want to add here is we have seen also a extremely rapid change of technologies for the customer for them to implement so-called AI factory. So if you take a look at what was, for example, H100 to H200 to the B200, B300, the difference of technology for cooling and power is totally different. So I think one of the elements which is going to be very important into the future is not the technology. It's not what I sell or what they sell. It's the agility that you can have with what I sell and what they sell. That element of agility, if you see today into, let's say, Singapore, there is some high performance computers who have been put at the national capacity. You can see that these are going to be with a life cycle which is going to be less than 20 years because the technology is going to change and they know that already. So there is an element of agility. There have been a concept of modularity that we have been talking about data center facility for many, many years, and people were taking that a little bit lightly up to now, because if you are not agile and if you are not modular, your new data center is already going to be maybe with the best technology, but it will be already out of date, out of capacity technically for the next generation. So this is also something which is quite important into the market today. Is there is technology, but there is a lot of change coming, and these changes are coming very frequently. If you look at, go back to my introduction, in the past when we were designing a data center, the rack that we were using and what we were putting into the rack was changing, but the variation was like very small. Today with AI, this technology is having an evolution which is extremely rapid and most important, very frequent. And you can see that, let's say you take, for example, the B200. B200 is coming 100% direct liquid cooling, no choice. The 300 is not the same. You can have cooling with liquid or no. So you see, now what do I do for my data center? Because people start to realize that actually there is different change. The other thing which is going to be interesting to see is if I have, let's say, a liquid circuit that I have to deploy into a data center with multiple generation. So what is my strategy to bring that cooling there? Because I'm going to have generation 1, generation 2, generation 3 on the same liquid cooling, I will say, circuit. Yeah. So how do we plan this circuit to become agile in the future? So all these kind of things are really elements that people need to put in consideration when they are going to plan for the future of their so-called AI factory.
So, any perspective you have on the cooling
Yeah,
side?
absolutely. So if you look at the data center space, and we are the few companies over a period of time has evolved ourselves to address the complete value chain, right? So if you look at the grid to chip and the chip to chiller offer required to address any AI factory or AI data center, we have solutions which can address those requirements. If I get more granular in terms of the gray space and the white space, you talk about 5 critical elements in a data center space. You're talking about power, you're talking about cooling, rack, rack observation, and then the software. We have all the elements required to address, and we have evolved that offer with HPE. So that's where our collaboration and working together comes into picture, and we will specifically get into those areas as we move forward. It is very, very important to understand that all these elements becomes a very critical part of 4 stages of a data center. You do the design with the customer. If you're looking at a greenfield data center, right? You look at the design of the data center, you build the data center. Now you have to maintain to deliver what you have promised, right? So you have to maintain and operate. We have all the elements required to deliver an effective data center for the customer, and that's where the efficiency comes into picture. So you design an offer for the day one and deliver the efficiency to day n. It can be from the power perspective and cooling perspective. And Christoph and Alicia were specifically referring to technologies which are available today to address the challenge of not only today, but what we are looking forward to in the next probably year or so.
Great. So, Christoph, you touched upon the GPU infrastructure, basically, which is the heart of an AI factory. So, what actually makes a rack AI ready, if you have to call it?
A rack ready start with first an infrastructure which is ready to host something which is going to be extremely dense in power. Okay, that means you need to find racks who are capable of delivering something like 100 kilowatt per rack, which is like 10 times bigger than the highest rack that we have today as an average. Okay, today the rack average is sometimes 3 kilowatt, but let's say if we go into the highest density of the low density rack, I will say is 10 kilowatt. We are talking about something which is 10 times more, and it's just the beginning. Yeah, there is people who are today starting to think about a megawatt or half of a megawatt. Okay, so it's a very, very dense environment in terms of I would say power distribution, because bringing 2 or 3 kilowatt into a rack compared to bringing 100 kilowatt, 200 kilowatt, 300 kilowatt, it changed completely the electrical design. And we are not talking about the 3-phase PDU that we had in the past. It's actually, you cannot bring that with a normal cable, because it's going to be too much power coming into one single feed. And this is going to generate issue at the electrical level, but also you will have maybe some problem of, let's say, electromagnetic field, right? Which is going to jam the network. Yeah. So there is a lot of things that you need to put in consideration for a rack ready to be ready to bring that energy inside. Okay. The second one is obviously a very advanced cooling system. Yeah. And this cooling system need to be also correctly defined and designed depending on what you want to put into the rack. Because depending on the equipment that you are going to have, the distribution of this cooling is going to change also. And today we have CDUs who can be at the row level, at the rack level, depending on what you want to do, how you want to be yourself or make yourself agile. Do you want to put the PDU or the CDU, into the rack or into the row? That is also something that people will have to discuss and define depending on the technology or the agility that they want to have, right? So these are the type of rack design, I would say, criteria that people need to think about. Yeah.
Alicia, in your perspective?
So yeah, Christopher is right. In today's AI environment, the unit of design have shifted from the chip to the rack, and this kind of changed everything about power, cooling, and operation. When the rack become the unit of design, the infrastructure kind of become the differentiator, and we no longer kind of design a server and mount it into rack. We kind of design the rack and put in the compute, and this entire rack behaves like a single supercomputer, and this is driving the growth of heterogeneity at inference rack cluster design. And to be able to deploy it based on a validated design together with HPE and Schneider is essential to ensure it is manageable and scalable.
Yeah. So, Christoph, does this mean that we are building these AI factories based on some standardized, scalable units?
Yeah, you have to, okay, because it cannot be heterogeneous. Okay, you are going to create a cluster, and even though you are not an hyperscaler, if you're an enterprise, that cluster is going to be quite constant. Yeah, so you cannot mix too many things. You can mix maybe one or two generation of, let's say, GPUs, but that's going to be, I think, the limit. You can see today people who are doing this supercomputer environment, they are usually not very big in dimension. They are big in capacity, but their dimension actually these are not extremely large data center. Yeah, there is some very large facility for, let's say, a company like hyperscaler who are going to build some very large site, but the customer footprint into the site is not very big. But the capacity, of course, is very powerful. But these clusters are very standard. Yeah, so yes, it will be one method of deployment, one method of operation. It's very important that you mention about operation, because that's maybe something that we can develop a little bit. Yes, Schneider is having a set of tools to observe what is happening into these so-called racks. We have also a set of observability tools to look at what is happening into this rack. It's just that we have different facets of observation. Yeah. They are looking at what is happening from a mechanical and electrical point of view. We are looking at what is happening into the network, what is happening into the compute, into the storage, and so on, right? So we have different views. What is important is, in the past, observability and automation was a good to have. Because yes, people wanted to have a good PUE. So you want to have a good power usage efficiency. So of course you need to measure properly to make sure that you are taking care of the power usage. In AI, this is even going into a complete different dimension. As you mentioned into your introduction, when there is a problem on a rack of 100 kilowatt, we are telling that there is a problem into the equivalent of maybe 50 houses who are actually currently running every single appliance full time, full capacity, and there is a problem of electricity into all of them at the same time. You can imagine that the time to respond to this kind of problem is going to be ultra critical for this type of operation, especially in inferencing. Yeah. So that observability, that monitoring is also entering into a new era, because today, again, nobody have been operating all this environment at scale, and they will probably realize very soon that actually they need to change their business operation procedure, because it's something that is so different compared to a normal rack, where today, if you have a 5 kilowatt rack which is having a problem, you have time to go and check the temperature and so on. Into that, you are talking about things who are really at thousands of degrees Celsius. So it's really a serious temperature elevation which is going to happen into this kind of racks. So when that happens, the time to react is going to be also very important. So the definition of the rack is important. The definition of the operation of this rack is also going to be very important for the future of our customer operation.
Great. So I think so far we touched upon cooling, we touched upon standardization. Now, if you have to move the conversation forward to an interesting area of prefabrication. So Anand, maybe on this I'll come to you, that tell us more about this modular AI-ready pods that we have.
And this is a very exciting point to discuss what we are seeing specifically in the market. But let's take a couple of steps back. What we are trying to do with prefab, right? What we are trying to address as a problem, we are trying to address plug and play. That means the time to market for the customer substantially reduces. And I would say that we have been working with HPE on addressing this challenge for a pretty long time. So if you remember the Edge Center, we have developed jointly to address certain challenges at that point of time with the customer. And today, if you look at recently, we worked together to address an automotive customer, where the customer was looking at data center transformation for 50 locations across the world. And the time to deployment was a challenge. We looked at prefab as an offer. We jointly created 3 t-shirt sizes, right? So small, medium, and large, and then made sure that it meeting the customer's short-term requirement, but technology roadmap, right? What they're going to deploy as a solution over a period of next 10 to 15 years. And we were able to address that requirement very fast. And the locations were were manufacturing locations, you know how difficult those locations are. So we were able to address them at a shorter period of time. So that's an interesting area to work with and address customer challenges.
Great. Alisa, your perspective?
Yeah, so yeah, you're right, Anand. So prefab actually plays a very critical role in current AI factory or modular data center deployment, because it's the fastest way to bring AI capacity online, as it's fully integrated with power, cooling, rack monitoring, factory integrated, tested. You build it, you ship it on site, rack and roll, and it's ready day one. And customers generate immediate value, as opposed to the traditional built data center where they take years to actually get it up and running. And what is best is you can pair it, because it's a self-contained unit and the load is very kind of well defined. You can pair it with behind the meter solution where you can have on-site generation and kind of energy storage system, which also kind of reduce the dependency on the grid. That is per se.
I can add to this, right? I think just before you were mentioning about these standardized and scalable units. Yeah. And I was also telling just earlier also that the technology is changing very quickly, right? So of course, the time to market advantage of a prefabricated, I think again, this is nothing new. Okay. It's just now we make it applicable to a different context. Okay. But go back to my point. These data centers and this technology are going to change very frequently, and the next generation will need a new cooling system because the container that we are talking about here are going to be designed to, let's say, maybe cool a system at 100 kilowatt per rack, because that was the design. But if now we are coming with a 200 kilowatt per rack, this doesn't work anymore.
Yeah.
Right? It may work because you have to, maybe now instead of putting 10 racks, then you will put 5 racks only, right? But again, this is no more profitable. It's all about money here, right? So to have that modularity, you remember modularity, agility. So not only it gives you the capacity to go in production faster than building a brick and mortar, yeah, but it also gives you that agility to say, okay, I bring forth this generation of AI, yeah, and then when the new generation is coming, I can actually take a different module, yeah, that I will put in production next to the previous one, which is coming again with this 10 rack capacity, but now is going to have for the next generation and the next generation. And then I can also remove the previous generation, put a new. So this modularity is becoming way more efficient now for the customer and the life cycle that we have into the industry. So modular is just at the beginning of its value proposition. It's no more just a time to market value proposition. That was true for the compared to brick and mortar. Today, we are designing factory AI per generation. Yeah. And so that modularity is there also with interchangeability. I should be able to plug and play my entire environment. It will be so much easier to operate also into that, right? It will simplify a lot of the operation procedure. But we are just at the beginning of that realization into the market.
Coming back to the AI workloads. So the point is that AI workloads may not be only in the core data center. I mean, if you take hospital or if you take retail, your AI ability will be required even at the edges. So what does this impact to the infrastructure in general?
Yeah, I mean, the impact is obviously we are going to have a set of infrastructure who are not used to be there, who are now going to be there. And again, that is going to make all this site not really by definition. And you can imagine, let's say, an hospital, yeah, which is now suddenly going to have to receive 100 kilowatt per rack. They will not have 20 racks. They may have 5-6 racks maximum. But again, the power distribution for this kind of environment is going to be so radically different that is going to be a challenge for this type of environment. We are talking about power and cooling, which is a good definition and discussion to have. But these racks are super heavy.
Mhm.
You cannot put that into a building, a normal building, because we are talking about racks who are, let's say, 2, and maybe they will go to 3 tons per rack. We don't know. And this is liquid. So you cannot put that in the middle of a building like that who haven't been, I would say, prepared for this kind of things, right? So that is obviously bringing that level of complexity into area who are even less ready than a legacy data center. Yeah. Second point, which is going to be a problem there, or something that we have to think about, is again the operation. Yeah? Because it will have to come not only with the mechanical and electrical capacity, but definitely the value coming from an operation monitoring is going to be very important, because you are going to have this fleet of very complex environment that you will have to manage from a central point. Because again, into this type of environment, you will not have the MEP specialist at disposition to just measure continuously, right? So operation also there is going to change. Communication is going to change. A lot of things are going to change there. So definitely coming with something which is prefabricated is going to be a value, but there will still need to be a need for additional monitoring, additional communication, because we will have to also inform the people who are operating into this, let's say, hospital or manufacturing plant whatsoever, that a new form of event is coming into the environment. Operational event, because they never get such stuff into this type of environment before. Yeah.
Elisa, your perspective?
Yeah, actually, I agree with Christopher. And the amount of AI capacity that is coming online at the edge is going to be huge. It's kind of forecasted at about 58 gigawatt of AI capacity is coming online into the edge. And it's projected by global analysts that 50% of AI workload will be deployed on the edge. And as mentioned by you, when we try to take a hyperscaler MEP design and try to deploy it at the edge, it just will not work, because it's a smaller space. You kind of compress 10 to 30 kilowatt of power into that small constrained space. It's a factory, it may be a retail back room, it may be in an office area, and it's also may not be logical to kind of build a data center room in every one of these edge data center in this, any one of these edge location. So it's essential that we work on a modular data center approach, which is pre-integrated, prefabricated, factory tested, as I mentioned, up and ready day one. And it's kind of speed up deployment by 30% compared to the normal, stick and build of a traditional data center.
Good. So Anand, if I take the conversation forward, so can we say that modular and edge will kind of go hand in hand?
They will coexist as we move forward. I'll take reference from what Alicia mentioned and Christoph was referring to in his conversation. The evolution from the colos, it will get into inferencing, and that's where the application comes into picture. The major adaptation will happen into industries, which is manufacturing, healthcare, easy adaptation, and then it will get into rest of the industries as the availability of the solution and application comes into picture. It is very, very critical to understand, and Christoph was referring to this in our conversation, is that the subject matter expertise will not be available in most of these enterprise, and that will be a major challenge to deal with. What we need to not only provide is a robust infrastructure which can sustain in this difficult environment, but also the ability to observe, because these are multi-location deployments. These are not located at single location. There are deployments across not only geographically dispersed location, but locations which are within the premises at multiple location, right? So we have to make sure we are observing them very clearly. We have the appropriate software which can maintain and understand what is happening within the premises. To answer specifically, Nusrat, yes, they will coexist as we move forward.
Great. So I think let's wrap a conversation with a concept which is very important, which is sustainability. So as we all know that the AI workloads are very power intensive. So for customers or organizations who are listening to this podcast, how will they balance, according to you, the responsibility of sustainability at the same time innovation? What's your views on that?
So sustainability should not be an afterthought, right? As people invest into the race of catching up with AI to make sure that their enterprise effectively utilize the same, their employees leverage to improve the overall efficiency. Sustainability should also be a part of that journey. And that comes from those 4 stages I happened to mention in our conversation earlier, which is the design. If they are looking at a green field, and this is primarily on the green field for a major reason, that if you are investing in terms of the load which you are bringing into the premises, the power consumption, the weight of the rack itself, you are looking at a new infrastructure, right? So if you are building a new infrastructure and looking at those 4 stages, it is important and imperative that you invest on the sustainability part from day one. And that's the journey we are looking at in terms of. So Schneider do have people, subject matter experts, who are able to address those specific areas of expertise required to address the sustainability as we move along. We have done a couple of activities with HPE over a period of last couple of years, which makes us more ability to address the IT part of it. Just to quickly refer, one of the opportunities which we were trying to address in Southeast Asia for a customer who was trying to deploy an AI, we leveraged a cooling optimized solution to make the customer understand what's the existing consumption of power, what's the heat load which is being delivered by the existing infrastructure. Can he increase from 5 kilowatt to 25, 40, or 50 as they move along? And we were able to do a decent job for the customer. So sustainability, not only for the greenfield, but also for the brownfield infrastructure as we get into the AI deployment at customers' premises.
Christoph, your perspective?
My perspective is very simple. If you plan to have a factory or AI factory with a PUE which is more than 1.2, your design is wrong. So if you don't operate between 1 to 1.2 as a very big maximum, your business will not make money. Okay, it's very simple, because we are talking about such amount of energy that if you have to waste 30% of that energy systematically, I don't know how you make business. It's a very cost-sensitive business. It's a huge opportunity of business, AI, but if you are not to the sense, I tell you, you will fail into that market. And knowing that 30% of the cost is on the cooling, if that 30% of cooling and power, which is another 40% probably, right? If that is done wrongly, and if you have a power efficiency where you systematically, for every single watt that you are going to spend, you basically throw 30 cents of money on top of that $1 of money, I tell you, there is no way you will make business in AI. No way. So it's very important that if today somebody is planning a data center for AI or AI factory, and if their design is not below a design PUE of 1.2 into our region, some other region can be even negative actually. But if you are not into that range, if you think that 1.3 will be good enough, you are already wrong. 1.2 is, in my view, that's personal, I think is a maximum that is, in my view, at the limit of the acceptance. Yeah, but 1.1 to 1.2, that's probably something that people need to target at design and definitely operate into that zone, which is not something easy to do. Yeah? Operating a data center at 1.1 is not a question of design. It's important to design it for it, but to operate it, it's something that people need to really think about. Probably we don't have enough time to talk about it today, but there is more than the design to achieve something like that, right? So I think people need to realize this kind of challenge before they engage too far into some technology who may look very fancy, but if they are not able to deliver that, ultimately, just forget it.
Got it. So before we close, Alicia, I think the last question to you. I mean, how does the HP and Schneider partnership is making a difference in this context?
Oh, I think HPE and Schneider partnership is like the best in class collaboration. Schneider being the world's most sustainable company in the world, and HPE is the builder of the fastest supercomputer and AI system. Not just fast, you all make it very efficiency. It's like, just take a step back. We cool 6 out of the 10 supercomputer, and you all built 6 out of the fastest supercomputer in the world. It's a very good case of compute efficiency meeting infrastructure and energy efficiency. And I believe together with this collaboration, we are able to help our customer drive sustainability at its core and also concurrently scale AI.
So thank you, Anand, Elisa, and Christoph for
Thank
an
you.
engaging and insightful conversation. And to our audience, one thing is clear. AI factories are no longer a concept which is future. They are here. The real question is, are your data centers ready? Thank you for listening, and bye for now.